We're on page 4 of our worksheet 5. This is numbers 18 through 22. The function f is given by, number 18, the function f is given by log base 10 of x. So that is f. Okay? The function g is given by log base 10 of x cubed. Oops. All right, which of the following describes the transformation for which the graph of g is the image of the graph of f? And I see here they're talking about dilations, factors of 3 and 1/3. So let's see. So they give me that g of x is log base 10 of x cubed. Okay. I want to morph this to where it has an f of x in it. So I'm going to move the 3 to the front, the power to the front of the log, and that's going to make it 3 log base 10 of x, which is exactly f of x. So this is 3 f of x. So g of x is equal to 3 times f of x. That is a vertical dilation of factor 3. Way back from unit 1, vertical dilation of factor 3 when you multiply a number times your function. So A. Number 19. The function f is given by f is ln of x. Which of the following describes input values? Input are the x values. Which of the following describes the x's for which the output values, the y's, are integers? We want the y's to be integers. What would I have to do right there to make it an integer? 1, 2, 3, 4, 5. What would I need to have there to make it a 1? I would have to have an e to make it a 1. What would I have to have there to make it a 2? I would have to have it e squared, because the 2 would come out to the front. ln of e is 1, 2. 2 times 1. What would I have to do to make it a 3? I would need an e cubed. So what describes the input values that make the output values integers? Integer powers of e. A. Great question. All right, number 20. The function g is given by a log base b of c. A, b, and c are positive integers. Which of the following is an equivalent representation of g? And I look at their choices and I can see they're asking, does the student know the properties of logs? And there is an easy property I see that I can do. I can move that coefficient and make it the power on the c. The power on the c. Which one is it? It's only the power on the c. So it's answer choice A. Number 21. The function f is logarithmic, and the points 2, 1, and 4, 2 are on the graph of f, which could be f of x. Okay? The points 2, 1, and 4, 2 are on the graph of f. That is logarithmic, and there's nothing funny going on here. Let's see. If you have a one-way, I don't want to just say the answer. If I had, let's make a table of values here, and let's sort through these. We see what the choices are. Let's say that we had x. Let's say that we had this one, log base 4 of x. If x is 2, would we get 1? No, we would not. We would not get 1 there, because if I put a 2 here, I'm not going to get a 1. I would need a 4 there, right? Let's look at this one, and it's choice B. What if I had a 2 log base 2? If I had a 2 in for x, log base 2 of 2 is 1. 1 times 2 is 2, not 1. So it's not that one either. Let's look at answer choice C. 2 log base 4 of x. Okay, if I put a 2 in, what is log base 4 of 2? What is log base 4 of 2? What power do you raise 4 to get 2? That would be 1/2, which is 1. That one checked out. Let's do the next one. If I put 4 in for x, do I get 2? If I put 4 in for x, log base 4 of 4 is 1, times 2 is 2. That one checks out. The answer is C. Okay, a little bit of a thinker one. Took a moment there. All right, number 22. We're given g of x. What are all the values of x for which g is less than 0? So I want ln of 3x plus 1 minus ln of x squared plus x minus 2. I want that to be less than 0. Okay. I could do this a couple of ways. I could combine these logs. If I combine these logs, I'm going to get a log with a rational argument. It's less than 0. It might be complicated to do it that way. I think instead I'm going to move this log to the other side. Okay, this might still be complicated, but let's see. So I have log of this is less than log of that. If that is true, if we take e to both sides, we just set our arguments less than. 3x plus 1 must be less than x squared plus x minus 2. This looks way better. Now I'm going to get 0 on one side. I'm going to move it over to the right because the x squared is positive over there. And I have that. So if I switch sides, because I like for my x's to be on the right, on the left, I need to switch the inequality sign if I switch sides. So this tells me x minus 3, x plus 1 is greater than 0. So these are the ones we just did these last unit. We're going to make a number line. On the number line, I'm going to put 3 and negative 1. That's where I see these 3's and negative 1's from over here. Okay, I'm not including either of these because it's not equal to. And now I'm going to put in some values. If I put a value in here like 5 or 10 or 100, I'm going to get a positive times a positive, which is a positive. And I'm going to switch signs around the 3 because it came from an odd-powered factor. And I'm going to switch signs around the negative 1 since it came from an odd-powered factor. And I want to keep the ones that are greater than. So I want to keep this one and this one. So the correct answer there, oh wait, I would keep this one. I would keep this one. But what would these values, if we have large negative values, what's that going to do to this guy right there? It will make it have a negative log. Can't have that. We can't have that there. We can't have anything less than negative 1/3. So we only keep the 3 to infinity. Ooh, that was a tricky one. Very tricky one. Again, for the sake of x cannot be, x x must be greater than negative 1/3. It must be greater than negative 1/3. Okay, maybe if I had done it the other way where I combined logs to begin with, maybe I wouldn't have had to deal with that. Or maybe I would have. Who knows? Okay,